Hello again, and welcome. I'm glad you're here. Maybe your day was full and long, or maybe it just felt that way, like time moved differently today. Either way, you've made it to this moment, where nothing is asked of you. You don't have to solve anything, move anywhere, or even stay awake. All that's left now is to rest. Let your body sink into softness. Let your breath grow slower, gentler. As your limbs grow still and the room dims around you, allow your thoughts to quiet, not by force, but by letting go. Like mist rising from a warm lake, let them drift and dissolve until only calm remains. Tonight, we're going on a journey, but you won't need a map. You won't need to follow every detail. Just listen and let the gentle rhythms of the galaxy carry you. Because the Milky Way isn't just a place above us. It's not something we look at from afar. It's something we belong to, something we're inside of, something that shaped us and continues to. The stars, though scattered across vast distances, are not separate from you. The calcium in your bones, the iron in your blood, the oxygen in your lungs. These came from stars that lived and died long before Earth existed. You are not merely looking up at the sky, you are made of it. Every heartbeat echoes with the chemistry of light. And the Milky Way, our spiral galaxy, our quiet glowing home, is not something we merely reside in. It is our origin, our context, our silent companion through time. As you settle in, know this isn't a lesson. There will be no quiz. You won't need to remember anything. What we offer here is curiosity wrapped in calm, a story told not in urgency, but in patience. There's no rush to get to the end. Each idea is a stepping stone placed gently on a trail of wonder. And if you fall asleep before we reach the last word, that's perfectly all right. These thoughts will still be here, floating like stardust in the back of your mind. And while you're settling in, before your eyes grow too heavy, I'd love it if you gently tapped subscribe or left a comment telling me where you're listening from and what time it is in your corner of the night. It's oddly fascinating to see where people are drifting off with us, scattered across the world like stars across the galaxy. Now take a deep breath, let your day drift away, and let's travel together into the quiet corners of the universe. Tonight, we begin with the galaxy itself, the Milky Way, named not from science, but from myth. Ancient people saw that pale river in the sky and thought of milk spilled by gods. A celestial stream poured across the dark. They were reaching for poetry, not precision, but somehow they weren't far off. Because the galaxy is a river, a current of stars, gas, dust, and memory, flowing through time and space. It bends, twists, and stretches like something alive, though it does not live. It spins like a wheel, slow and massive, turning once every few 100 million years. From Earth, we see only a narrow band of it, a shimmering arc in the darkest skies when clouds and city lights stay away. What we're seeing is the cross-section of a disk. We're inside it, looking through it, the way someone in a forest might look between the trees and see only the trunks. We cannot step outside of our galaxy to see it whole. We piece it together instead, one quiet observation at a time. There are over 100 billion stars in the Milky Way. Many are small and faint, glowing just enough to warm their nearby planets. Others burn blue and hot, short-lived but brilliant. Some are alone, others in pairs or clusters. Some are newborns wrapped in gas. Others are ancient, older than the galaxy's own spiral arms. And among them, drifting softly, are clouds of gas that haven't yet become stars, waiting, perhaps, for the right nudge from gravity or a passing wave of pressure. And that's just the visible part. Surrounding the Milky Way is a vast halo of stars, of dark matter, of things we're only beginning to understand. The galaxy is held together not by what we see, but by what we cannot. Invisible forces sculpt its form, pull its arms, and shape its motion. We are riding in something immense and mysterious, held fast by gravity, yet surrounded by unanswered questions. As you breathe gently now, know that the galaxy breathes too, not in air, but in cycles of energy and matter. Stars are born, they shine, and they die. Their remains drift outward, mix with dust, and form new stars, new planets, new chances. Nothing is wasted. Everything becomes something else. And this cycle of creation and destruction doesn't happen in noise or chaos, but mostly in silence. The galaxy doesn't roar, it whispers. It hums in frequencies too low to hear, in wavelengths too long for our eyes, but it speaks just the same. In the chapters to come, we'll drift from the spiral arms to the hidden core. We'll pass rogue stars flung into darkness and find ancient remnants glowing faintly on the edge of everything. We'll learn why the galaxy is warped, how it feeds on others, and why stars don't always follow the same direction. Some of what we explore may surprise you, some may comfort you, and some may simply pass through you like a breeze. I noticed, but not held. That's the beauty of it. Let yourself be unhurried. Let curiosity be soft. Imagine your body floating just slightly above the mattress now, as if the weight of the day has finally melted away. The sky may be dark outside your window, but above that darkness, stars are still burning, planets are still spinning, and the Milky Way, luminous and slow, is turning like a great wheel you never noticed until now. You don't need to do anything. You're already part of it. You've always been. The story of the galaxy is not something told to you from a distance. It's something written in your skin. The atoms of your body were born from events too distant to imagine, and yet here you are, warm, breathing, listening in the dark. So close your eyes, if you haven't already. Let go of the hours behind you and stop reaching for the ones ahead. Tonight, we begin. And there's nowhere you need to go but here. The galaxy is not a still picture. It is not frozen in the sky like a painting on a ceiling. It moves. It flows. And we are flowing with it even now, even as you lie in silence. Beneath your stillness, the earth turns, the moon orbits, and the entire solar system drifts gently along a vast and spiraling path. You are not anchored. You are adrift inside a structure so wide, so layered, that it cannot be seen from within. But that structure has a name, the Milky Way. The Milky Way is our galaxy, our city of stars. It is not the universe, only our corner of it, one of perhaps trillions of galaxies that fill the cosmos. And like many of them, it is a spiral galaxy, shaped like a glowing pinwheel spinning slowly in the dark. From afar, it might look delicate, but it is enormous. Over 100 light-years across, containing hundreds of billions of stars, each with its own orbit, its own path, its own quiet journey through time. We cannot see the spiral from here. We live too deep inside it, but we can feel it in the motions of the stars. We can map its arms by watching how light bends and dust obscures. And what we've found is that the Milky Way is not a simple disk. It is a barred spiral galaxy, meaning that at its center is not just a round bulge of stars, but a bar, an elongated structure glowing faintly beneath veils of dust. This bar rotates slowly, like the core of a wheel, and from its ends spiral arms emerge, sweeping outward in grand arcs. The spiral arms are not solid. They are not lines of stars fixed in place. They are patterns, density waves, like the ripple of cars through traffic, or the motion of wind through a field. As gas and dust pass through these waves, they are compressed, and new stars are born. That is why the arms shine with bright, young stars. They are regions of birth and movement, illuminated by energy, shaped by invisible forces. And between these arms, quieter regions flow, filled with older stars, less crowded, more diffuse. Closer to the center, the stars are packed more tightly. The galactic core, though hidden from our eyes by clouds of interstellar dust, is home to a dense population of stars orbiting rapidly around a dark center. There, near the heart of the galaxy, gravity rules with quiet authority, and though we cannot see it, we know what lies there. A supermassive black hole, millions of times the mass of the Sun, turning silently in the center of it all. Beyond the arms and the core lies the halo, a vast, spherical region that surrounds the disk like a distant shell. It is not empty. It holds ancient stars, globular clusters, and streams of light left behind by smaller galaxies long ago absorbed. It also holds something we cannot see: dark matter, a form of mass that emits no light, cannot be touched, yet holds the galaxy together with its invisible gravity. Without it, the Milky Way would not spin the way it does. The arms would unravel. The stars would drift. But dark matter binds it all, like scaffolding made of silence. And where are we in all of this? We are not near the center, not near the edge. We live in a quiet suburb of the galaxy, tucked inside a small lane of stars called the Orion Spur. It's not one of the major arms, not grand like Sagittarius or Perseus. It's a minor structure, a branch between highways, but perhaps that's why we're here. It's calmer, more stable, the kind of place where life has time to unfold without too much disruption. Our sun orbits the galactic center at an astonishing speed, over 800 kilometers per hour, and still, it takes about 225 million years to complete just one loop. In all of Earth's history, the solar system has only gone around the galaxy a couple dozen times. When the dinosaurs roamed the planet, we were in a different part of the spiral entirely. The stars in our sky were arranged differently. The night was lit by unfamiliar patterns, and millions of years from now, it will be again. The stars are not fixed. They are not decorations on a ceiling. They move. Some orbit quickly, close to the core. Others drift slowly in the outer reaches. Some travel in tilted paths, above and below the disk, and we are moving with them, caught in the swirl, part of the dance. The galaxy does not sit still. It rotates, breathes, evolves. Over time it grows, changes shape, absorbs others. Its arms may shift, its center may flare. Its stars are born, die, and are replaced. Nothing remains as it was. And yet, from within, it feels calm. Lying here, you do not feel the motion. You do not feel the gravity pulling at stars across tens of thousands of light years. You do not feel the slow turning of the spiral or the subtle ripples in its structure. But they are there, all the same. Every moment, the Milky Way moves, and you move with it. In stillness, you are a passenger inside a spiral of stars, not just an observer, not just someone beneath the sky. You are within it, wrapped in its arms, turning in its current. You are part of the pattern, part of the shape, part of the slow, beautiful motion that has carried stars across billions of years. You are home in a spiral of stars, on clear, dark nights, far from the glow of streetlights and headlights and screens. You might look up and see a pale ribbon stretching across the sky. It doesn't shimmer like the moon. It doesn't blink like the stars. It hangs there, quiet and soft, like a memory that never fully fades. That ribbon is the Milky Way, a gentle brush of light smeared across the heavens, delicate and distant, as if the night sky itself remembered something ancient and tried to paint it back into view. But what you're seeing isn't the whole galaxy, not even close. That faint glow, as wide as your outstretched hand and barely visible to city-born eyes, is only a sliver, a glimpse through a narrow window. The Milky Way is all around us. We are inside it, wrapped in its spiral arms, turning slowly in its vast embrace. Yet, from our vantage point on Earth, we see only a thin, bright band. That's because we're looking along the grain of the galaxy, along the disk, not across it. Like standing inside a forest and looking sideways through the trees, we see more trunks, more depth, more layers. But we can't see the shape we're within. The sky is not an open view, it is a slice. And even that slice is filtered. The human eye, miraculous as it is, can only detect a narrow range of light, a tiny fragment of the electromagnetic spectrum tucked between infrared and ultraviolet like a thread in an unseen fabric. The stars do not limit themselves to this range, nor does the galaxy. Most of what happens in the Milky Way glows in other kinds of light, frequencies our eyes were never built to see. We are not missing it because it is not there. We are missing it because we are not designed to see it. The visible light that does reach us arrives after a long and difficult journey. It travels from stars scattered across the galaxy, some nearby, some impossibly far. And along the way, it weaves through clouds of interstellar dust. These clouds are not thick, but they are enough. Enough to scatter and absorb light, enough to dim stars and erase shapes, enough to turn entire regions of the sky into soft, dark patches that appear empty but are anything but. Behind those curtains lie stars by the thousands. Behind every blank spot, a constellation too faint to find. Even the central bulge of our own galaxy, where stars are most densely packed, remains hidden behind a wall of dust. We know it's there not because we can see it, but because we've learned how to look differently. Not with eyes, but with instruments. Telescopes tuned to the invisible, built to see what we cannot. Through infrared and radio waves, the galaxy unfolds. Dust becomes translucent. Hidden stars emerge from shadow. The disk reveals its warp. The core burns faintly through the fog. Infrared light, with its longer waves, slips between dust particles. It glides where visible light is scattered, cutting through the veil and carrying with it the shapes of stars, nebulae, and galaxies behind galaxies. When we tune our instruments to these wavelengths, the night sky transforms. What once looked quiet becomes crowded. What seemed empty becomes rich. We find places where stars are being born, cloaked in thick clouds. We find structures we didn't know were there. We see the Milky Way not as a streak, but as a living structure. Textured, layered, evolving. Radio waves go even further. They can pass through dust as if it isn't there. They reveal hydrogen clouds stretching across thousands of light years. They map the skeleton of the spiral arms. They trace the warp of the galactic disk, bent by the tug of unseen forces. In radio light, the galaxy hums with complexity. Structures emerge that were once hidden, shells of gas left behind by ancient supernovae, streams of matter stripped from smaller galaxies, the ghostly trails of motion written across time. And so, the sky you see is not the full story. It is the topmost layer of a much deeper tapestry, a river of light that appears calm but carries multitudes. The Milky Way is not a narrow band, not really. It is a vast, glowing sea of stars, gas, dust, and memory. The band we see is the dense heart of the galactic plane, edge-on from our point of view. Everything outside of it, the halo above, the halo below, blends into blackness too sparse or too faint to draw the eye. If you've ever stood under the stars and felt small, you were seeing only the thinnest slice of what's truly there. The rest is hidden, not by distance alone, but by dust and limitation. It is hidden in wavelengths we cannot sense without tools. It is hidden behind time and space, and still we try to uncover it, slowly, patiently, listening for light beyond light. The Milky Way doesn't conceal itself with cruelty. It does not hide to tease or deny. It is simply vast, and we are small. It is old, and we are new. It glows in colors we did not evolve to see. But with each new way of looking, each new telescope, each fresh eye turned toward the sky, we see a little more. We fill in the map. We add depth to the ribbon. We realize that what we thought was a soft blur is a crowded city of stars, alive with motion, radiant with energy, and far more intricate than it first appears. So the next time you see the Milky Way, remember what you're truly looking at. Not just a strip of starlight across the sky, but a window into something wider, a river of light that runs beneath our perception, a current of energy that has carried stars and dust for billions of years. You are inside it, part of it, built from it. And even in the darkness, even in sleep, you are wrapped in its gentle glow. Stars are not born alone. Though they may grow old in solitude, though they may die without a witness, their beginnings are shared. They emerge not as single flames flickering into the dark, but as constellations of light born together in dense, hidden nurseries. Inside thick clouds of gas and dust, gravity gathers what once drifted freely. The cloud collapses in on itself, and within it, hundreds, sometimes thousands, of stars ignite almost at once, like a spark striking dry kindling. These are star clusters, cradles of fire suspended in the void. Some clusters are loose, their stars young and scattered, glowing brightly and moving apart even as they form. These are open clusters, temporary families drifting through the galaxy. Their stars are bound together in youth, but not forever. As time passes, their shared gravity weakens. The stars are pulled by passing clouds, by the nudges of nearby objects, by the invisible tides of the galaxy itself. One by one, they stray from the group. In a few 100 million years, what was once a tight cluster becomes a scattered memory, its members indistinguishable from the general population. They become field stars, loners whose origins are no longer obvious. The Pleiades is an open cluster. You may have seen it before, without even realizing. A tiny grouping of bright blue stars nestled close together in the night sky, often mistaken for a smudge or a dip in the stars. Through a telescope, they appear wrapped in delicate veils of gas. They are young, only about 100 million years old, just barely begun in cosmic time, and still moving together, though already drifting apart. One day, they will vanish from one another's company, but for now, they hold on to their shared beginning. Other clusters last longer, much longer. These are the globular clusters, ancient, spherical collections of stars packed densely into small regions of space. Some contain hundreds of thousands of stars, all orbiting a common center. These clusters are not scattered across the disk of the galaxy, but found in its halo, above and below the spiral plane, like satellites in slow, looping orbits. They are older than nearly everything else. Some are nearly as old as the galaxy itself, over 12 billion years in age. They orbit slowly, like memories that haven't faded. Their stars are old, faint, and red, long past their fiery youth, but still glowing with quiet dignity. When we look into a globular cluster, we're seeing deep into time, into a population of stars that formed before Earth existed, before the sun had even been imagined by the dust that would one day create it. These clusters hold the fossil record of the galaxy, not written in stone, but in light. Our sun was born in a cluster too. It had siblings, dozens if not hundreds of them, stars that shared the same cloud of origin, the same spiral of collapse. For a short time, perhaps a few million years, they orbited the center of their cluster together, surrounded by the remnants of their birth cloud. But as with all open clusters, time was a thief. The siblings wandered. Some moved inward, toward the galactic center. Others may have traveled far outward, or upward, into the halo. Our sun took its own path, and now we can no longer recognize its family by sight. But they're still out there, somewhere in the Milky Way, the The sun's long-lost siblings are burning. They shine in the night, indistinguishable to the naked eye from other stars. But through careful observation, through studies of composition, age, and motion, we are beginning to find them. Stars with the same elemental fingerprint, the same peculiar balance of metals, the same rhythm of spin. A family separated not by time alone, but by space, moving in slow orbits through the galaxy like strangers in a crowded city who once shared a childhood but no longer recognize each other on the street. The galaxy is not still. Every star you see is moving, including our sun. We orbit the galactic center at hundreds of thousands of kilometers per hour, tracing a path that has taken us around more than 20 times since the Earth first formed. And this motion is not smooth. It is stirred by gravity, distorted by mass, altered by encounters. Stars do not always stay where they were born. They migrate. Over millions and billions of years, stellar orbits change. They drift outward or inward. They rise above the galactic plane or sink below it. Some stars are caught in waves of density and drawn along spiral arms. Others are nudged by the gravity of passing stars or the silent tug of dark matter. The galaxy is like a sea, and its stars are drifting islands, moving in currents we cannot always see. This migration blurs the map. It scatters clusters and spreads siblings across impossible distances. A star born in the inner galaxy might now shine in its outskirts. A star that began near us may have long since traveled into the depths. But in every case, each star carries its origin with it, not in memory, but in chemistry. The composition of a star holds clues to the cloud that formed it, the conditions of its birth, the elements it inherited from previous generations. If we read those clues carefully, if we watch how they move, we can begin to reconstruct the stories lost to time. And so the stars, though scattered now, remain connected. Their families may no longer cluster in space, but the bonds of origin endure. Every open cluster dissolves, but the stars it formed are still siblings, even if they have forgotten. Every globular cluster endures, but grows old together, holding tight against the slow unraveling of gravity. You are surrounded by stars that once belonged to clusters, once shared their light with dozens of others. Even the sun, warming your skin, was never alone. It was born in light, beside others, in a cradle of dust and fire. And though it has traveled far, and though its siblings are distant, their shared origin still pulses softly beneath the surface. In the quiet darkness of space, nothing truly begins in isolation. Even the stars begin together. Between the stars, the galaxy is not empty. Though it may seem like the light shines through a void, the space between stars is filled with something subtler, something quiet, dark, and alive in its own way. The interstellar medium, as we call it, is a thin mixture of gas and dust, stretched across light years, drifting in silence between suns. It is sparse beyond human comprehension, thinner than any vacuum we can create on Earth. And yet it is the raw material from which stars are born and galaxies are shaped. It is the breath of the Milky Way itself, exhaled in starlight, inhaled in shadow. Most of this material is hydrogen, the simplest and most abundant element in the universe. A single proton, a whisper of mass. And yet when enough of it gathers in one place, it can become something immense. Alongside it, dust grains, tiny particles made of carbon, silicon, ice, and metal, float like soot in the dark. These grains are small, barely more than specks, but they are powerful in their effect. They scatter light, they block starlight, they cool the gas around them. They give the interstellar medium texture, depth, mystery. Sometimes, in certain regions of the galaxy, this medium collects into something more, a molecular cloud, dense, cold, and massive. These clouds are some of the coldest places in the galaxy, just a few degrees above absolute zero. Here, atoms move slowly, molecules form, hydrogen binding to hydrogen, creating a more complex, quieter state. These clouds can be enormous, stretching across hundreds of light years, and yet they are almost invisible to the naked eye. You may have looked right through one without knowing it. Their presence is felt not by what they show, but by what they hide. When you look up and see a starless patch in an otherwise glittering sky, that darkness is not an absence, it is a presence. A dark nebula, a molecular cloud so thick with dust that it obscures the stars behind it. These are the quietest places in the galaxy. No light, no noise, no movement that we can see. But deep inside, something is happening. Gravity is whispering, pulling, coaxing. Gravity is the sculptor of the Milky Way. It shapes everything, patiently and without haste. It gathers the scattered particles, gently nudging them closer over thousands, sometimes millions of years. It compresses the gas until clumps form, and within those clumps, deeper knots of matter collapse further still. The pressure builds, the core grows hot, and then, suddenly, a star is born. Not with a bang, but with a glow, hidden inside the cocoon of the cloud, invisible at first, quietly igniting. These stellar nurseries are places of transformation. Inside them, gravity takes what is diffuse and makes it dense, what is cold and makes it burn, what is formless and gives it shape. The new stars do not emerge cleanly. They stir the cloud. They push away the gas with winds and radiation. They light up the dust with their warmth. Some pierce through, shining bright and young. Others remain swaddled, their light only detectable in infrared, their presence still a secret. A single cloud might give rise to dozens of stars, hundreds, sometimes more. And in time, their heat and motion break apart the very cloud that created them, dispersing the gas back into space. The nursery is undone by its own children, and the cycle begins again. Matter released by one generation becomes the seedbed for the next. Nothing in the galaxy is truly still. Everything participates in this breath, inhaled by gravity, exhaled by starlight. And in between the clouds, between the clusters and the glowing regions of gas, lie vast stretches of what seems like emptiness. These are not molecular clouds, not dense enough to birth stars. They are the diffuse interstellar medium, where atoms drift alone, far apart, and the dust is too thin to block the light. But even here, the galaxy breathes. Energy from supernovae and stellar winds moves through this space, stirring it like wind over the surface of water. Waves ripple, pressure changes, regions compress, then expand again. The medium responds to everything. It is a canvas of responses, shaped by what came before and preparing what will come next. There are places where old stars have died and released their contents into the medium. Carbon and oxygen forged in their hearts, now scattered into space. There are places where that material gathers again, invisible to the eye, but destined to become part of a future sun, a future planet, perhaps even a future life. Nothing is lost. The interstellar medium is not empty space. It is memory. It is potential. It is the raw breath of the galaxy, waiting. If you could see in all wavelengths at once, you would see the Milky Way breathing. The spiral arms not as static structures but as dynamic flows of gas and light, dust lanes curling like smoke through the stars. Infrared clouds glowing faintly in the cold. Radio waves tracing the outlines of things not yet formed. Light shows you what already burns. Shadow shows you what is still becoming. And so the galaxy is not just stars. It is what lies between them. The dark matter, the dust, the hidden gases waiting to be stirred. The cold quiet where gravity works in secret. These are not the parts left over. They are the origin. Every bright star you've ever seen began in shadow. You live in a galaxy that breathes, not in minutes or hours, but in epochs, in the slow inhalation of dust gathering into clouds, in the exhale of light from new stars, in the vast pauses between one formation and the next. You do not feel it. You are too small, and the rhythm is too slow, but it is there, all the same. The galaxy breathes in light and shadow, and you are held in the quiet between. In the beginning, it is cold. Not just the kind of cold you feel when the wind cuts through a winter coat, but a silence deeper than anything your skin can register. A cold that moves slowly, without direction or urgency, the kind that has waited for millions of years without changing. Within this cold, clouds of gas drift through the galaxy, almost invisible, tendrils of hydrogen and helium suspended in space like forgotten breath. They are dark, hidden behind dust, unremarkable to any eye not trained to see beyond the ordinary. And yet, they carry within them the potential to become stars. Star formation does not begin with fire. It begins with stillness. Gravity, subtle and insistent, tugs at these clouds. It gathers gas particle by particle, tightening the weave, pulling everything closer. Denser regions form, knots within knots. And these knots grow heavier with time, collecting more mass, more momentum. There's no sudden shift, no flash of light to mark the moment. Just a long, slow contraction. The core of the cloud compresses, the pressure builds, and somewhere deep inside, friction gives way to heat. The heat rises silently until, at last, the hydrogen atoms begin to fuse. And that is when a star is born. Fusion is not an explosion. It is a kind of ignition that sustains itself. An eternal flame lit in the heart of a collapsing world. At first, the newborn star is hidden from view, still cloaked in the dust that made it. But soon it begins to push back. Its light and heat carve away the cloud around it, clearing a space, announcing its presence. The radiation from the young star strikes the surrounding gas and causes it to glow. This is an emission nebula, light not reflected, but created, sculpted by ultraviolet rays. These clouds, once cold and quiet, now shine in pinks and purples and blues, brilliant in false color, burning softly with the joy of arrival. The Orion Nebula is one of these places. It sits just below the belt of Orion, visible to the naked eye on a clear night. Through a telescope, it reveals the trapezium cluster, 4 young, hot stars nestled within a glowing cloud of gas. They are carving the nebula even now, shaping its filaments with stellar winds, illuminating pockets where more stars wait to be born. The light we see from them tonight left thousands of years ago, and still it travels. These stellar nurseries are not quiet places. Though sound cannot travel in the vacuum of space, the energy in these regions is immense. Ultraviolet light floods the area, ionizing atoms and heating the gas to thousands of degrees. Shock waves ripple through the cloud. Jets of matter burst from forming stars and crash into the surrounding medium, stirring up bright knots of activity. Each new star reshapes the conditions for the next. Some will be squeezed into being by these disturbances. Others will be smothered before they have the chance. This process, the birth of stars, is what lights the galaxy's spiral arms. The arms are not solid structures, not fixed in place. They are waves of density, moving slowly through the disk, gathering matter as they go. Where gas collects, stars begin to form, and their light marks the passage of the spiral wave. It is the ultraviolet light from the youngest, hottest stars that gives the arms their brilliance. These stars do not live long, only a few million years. They burn blue and bright, and then they end in silence or fury. But while they shine, they define the galaxy's shape. Everything in the Milky Way is touched by this light. It spills across vast distances, shaping the structures around it. It is light too energetic for human eyes, but not beyond our reach. Instruments tuned to ultraviolet wavelengths reveal it in detail. Brilliant arcs, sweeping curves, clusters of stars glowing at the heart of every nebula. We see where the new stars are. We map the rhythm of birth. And we remember, when we look closely, that we are part of this rhythm too. The hydrogen that fuses inside young stars is the same hydrogen that formed after the Big Bang. The carbon, oxygen, and nitrogen within your body were forged inside earlier stars. Ones that lived, died, and released their elements back into the galaxy. Supernovae scattered iron across space. Dying red giants exhaled carbon into the interstellar medium. Over billions of years, that material drifted, joined clouds, was gathered again by gravity, and eventually found its way into the dust that formed the solar system, into the rocks that became Earth, into the molecules that became you. You are made of stardust. Not metaphorically, literally. Every cell in your body contains atoms that were once inside a star. Every breath you take is part of a cycle that began in the cold quiet of a molecular cloud and passed through fire to arrive here. Your bones are built from calcium, forged in the hearts of dying giants. Your blood carries iron that once drifted between the stars. You are the dust returned to light. And even now, new stars are forming. Somewhere, right now, in the arms of the Milky Way, another cloud is collapsing. Another knot of gas is heating in the dark. Another fusion reaction is beginning. And one day, the light from that star will reach us. Long after you are gone, long after this moment has passed. The cycle continues. The breath deepens. The galaxy, still birthing stars in shadow, carries forward everything that ever was. It does not remember you as a name or a face. It remembers you as matter, as light, as part of the long story that began before you and will continue long after. The galaxy is not just where stars are born. It is where you were born. And when you sleep beneath the sky, you sleep inside that same cradle, wrapped in light you cannot see, held by gravity you cannot feel, made from dust you do not remember. But the stars remember, and they shine with everything you came from. Not every star dies in fire. Some simply fade, slowly surrendering their light to the dark, a soft and silent departure that leaves no trace to the unaided eye. Others, however, go with such force that they change the shape of space around them, their final breath echoing for millions of years. The death of a star is not a singular event, but a spectrum of farewells, shaped by mass, by age, by what the universe gave it to begin with. Yet no matter how they end, gently or violently, all stars give something back. Nothing in the galaxy is wasted. Even death, here, is a kind of beginning. Small stars like the sun do not explode. They live long, steady lives, 10, 20 billion years, burning hydrogen into helium with quiet resolve. When they exhaust their core fuel, they expand into red giants, their outer layers swelling, thinning, glowing with a strange red breath. For a time, they pulse, growing and shrinking, shedding layers into space like old skin. Eventually, their cores are left bare, hot, dense, and about the size of Earth. These are white dwarfs, the remnants of what once was, glowing faintly with residual heat, cooling over billions of years. They no longer fuse atoms. They no longer change. They simply persist. An ember in the dark. A white dwarf is incredibly dense. A teaspoon of its matter would weigh as much as a car. It is not quite dead, but it is finished. It will never shine as it once did, but its presence lingers. Around it, the gas it shed, carbon, oxygen, helium, drifts into space, lit by the leftover light, forming a planetary nebula that glows like a ghost for a short time. Eventually, the gas dissipates into the interstellar medium, becoming part of the galactic fabric again. The star has ended, but its material remains, waiting to be gathered once more. More massive stars follow a different path. They live faster lives, burning hotter and using their fuel in only a few million years. When they reach the end of that fuel, the balance that held them together breaks. Gravity wins. The core collapses inward in a fraction of a second, and the outer layers rebound outward in an explosion more powerful than anything else in the galaxy. A supernova. In that moment, the star outshines everything around it, releasing more energy in a few days than the sun will emit in its entire life. In the heart of the explosion, something astonishing happens. New elements are born. The violence creates temperatures and pressures high enough to forge gold, uranium, cobalt, and other heavy elements. Atoms too complex to form in the quiet heat of normal stars. These newly made elements are scattered into space, carried by the shock wave of the explosion. In this way, stars seed the galaxy with the ingredients for planets, for oceans, for breath and bone. The iron in your blood may have come from such an event. You carry the ashes of a supernova within you. What remains after such a death depends on the mass of the core. Some become neutron stars, ultra-dense remnants made entirely of neutrons, packed so tightly that a sugar cube of their material would outweigh Mount Everest. They spin rapidly, sometimes emitting beams of radiation like cosmic lighthouses. We call those pulsars. They are small, fast, and strange, and though they no longer shine like stars, they are powerful reminders of what once was. If the star was even more massive, the collapse does not stop. It continues past the neutron stage into something deeper, darker, and invisible. A black hole, a place where gravity has become absolute, where not even light can escape. It is not a hole in the traditional sense, but a region of space so warped by mass that it folds in on itself. What falls in, stays in, not lost, perhaps, but unreachable. And yet, even these most final of deaths contribute. A black hole may draw in surrounding gas and dust, heating it as it spirals inward. That heat can emit X-rays and other high-energy radiation. Some black holes, when fed, become quasars, galaxies with glowing hearts that can outshine their own stars. So even in their silence, they speak, they shape, they participate in the ongoing story of the Milky Way. These stellar deaths, whether quiet or cataclysmic, are not ends in the way we often imagine. They are part of a process, the galaxy's method of renewal. The material released by dying stars doesn't vanish. It joins the interstellar medium, enriching it with metals, molecules, and energy. This enriched gas may someday gather again in a cloud. That cloud may collapse, and in its center, a new star may be born. That star may host planets. Those planets may form oceans. And perhaps, on one of those planets, life may arise, composed of atoms that once pulsed inside a distant dying star. Each generation of stars builds on the last. The first stars, long gone, were made only of hydrogen and helium. Their deaths seeded the galaxy with the first heavy elements. The second generation used those, lived, died, and scattered more. We are now in the third generation, or beyond, made from a galaxy that has lived and died and lived again, over and over. The Milky Way is not static. It is stitched from endings. Each glowing star, each spinning planet, each breath of air is the result of a death long past. This recycling is not immediate. It takes hundreds of millions of years, but it is thorough. It is relentless. Nothing is wasted. The galaxy is vast and slow, but it remembers everything. Not in words, not in stories, but in atoms, in the presence of iron, of carbon, of silicon and sulfur. It remembers in the minerals of comets, the ice of moons, the soil of Earth. And so, as you look up at the night sky, remember that those points of light are not only shining, they are aging. Some may already be gone, their light still on its way. Others are just beginning, fueled by the gifts of those that came before. Every light is a line in the same story, and though the stars die, the story does not end. It becomes you. At the center of everything, there is silence. Not the absence of sound, but a kind of gravitational stillness, a pause in the fabric of the galaxy where matter itself holds its breath. The Milky Way, for all its sweeping arms and scattered suns, turns around this one invisible anchor, an object so massive, so dense, and so strange that light itself cannot leave it. It does not shine. It does not flicker. It does not reveal itself in any ordinary way. And yet everything around it moves in quiet obedience, drawn into its orbit like leaves around a drain. This is Sagittarius A, the heart of the galaxy. A black hole so massive it holds 4 million times the mass of the Sun within a region no larger than the orbit of Mercury. You cannot see it, but you can see what it does. For years, astronomers have watched stars near the galactic center, tracking their motions over time like slow dancers caught in a whirlpool. Some follow wide, lazy ellipses. Others whip around in tight, furious curves, completing an entire orbit in just a few years. They move with speeds that defy intuition, bending around an invisible point with such precision that only one explanation makes sense. They are orbiting something massive, compact, and dark. Not a cluster of stars, not a ball of gas. Only a black hole, silent and singular, could hold them like that. These stellar paths are not random. They draw out an invisible cage of motion, mapping the presence of something that cannot be touched or seen directly. Sagittarius A reveals itself only in how it shapes the dance. The black hole sits motionless in the middle, while stars wheel around it like moths circling a flame they cannot see. This is how we know it is there, not through its light, but through its gravity. A black hole is not a hole at all, but a place where mass has collapsed beyond the ability of space to contain it. At its core, all known laws of physics fall away. Time stretches, distance folds. The edge of a black hole is called the event horizon, the boundary beyond which nothing can return. Not light, not sound, not memory. What lies inside? No one knows. But outside, its influence is vast. Sagittarius A doesn't pull stars in like a cosmic vacuum. It holds them in orbit, shaping their paths, defining the curvature of space at the galactic center. Despite its immense gravity, Sagittarius A is quiet. It is not feeding voraciously like some of its cousins in other galaxies. There are no great jets of energy streaming from its poles, no bursts of radiation tearing through space. It is, for now, a sleeping giant. Every so often, it wakes enough to nibble at a passing cloud of gas, sending out a flicker of X-rays, a whisper of activity. But mostly, it waits. And while it waits, the galaxy spins around it. The presence of a supermassive black hole at the heart of the Milky Way is not unique. Nearly every large galaxy we've observed seems to have one. Some are billions of times more massive than the Sun. Some are active, bright, and ravenous. Ours is calm, dormant, but its role remains fundamental. It is not a destroyer. It is an organizer, a shaper. Without it, the gravitational structure of the galaxy would be different. The stars in the inner regions would move differently. The spiral arms might never have taken form. Galaxies and black holes grow together. It's a relationship still not fully understood. The mass of a galaxy's central bulge, the dense cluster of stars surrounding its heart, seems tied to the mass of its black hole, as though one responds to the other across time. Some theories suggest black holes help regulate star formation, heating surrounding gas and slowing its collapse. Others point to feedback loops. Matter falling into the black hole generates energy, which affects the flow of matter in the galaxy, which in turn shapes what the black hole can eat. Whatever the mechanism, The connection is real. The fate of a galaxy and the fate of its black hole are intertwined. Even as it sleeps, Sagittarius A exerts influence. It is a reminder that gravity is not always loud, that power can be invisible, that the strongest force in the galaxy does not shout. It waits, patient, still, certain, and it has waited a long time. The stars near it are ancient, forged in the earliest days of the galaxy. Dust and gas swirl in complex orbits, sometimes falling inward, sometimes swept away. Occasionally, a star will wander too close and be shredded by tidal forces, its material forming a glowing disk before vanishing. But these events are rare. More often, the black hole is content to remain hidden, wrapped in the blur of stars and dust that crowd the galactic center. The light from this region takes 26 years to reach us. When we look toward the center of the Milky Way, we see it not as it is now, but as it was when early humans first painted on cave walls. Even now, our view is obscured by clouds of gas and dust, blocking visible light and forcing us to see in radio, infrared, and X-ray. We piece together a picture from the shadows, from the edges, from what is implied by motion and heat. But still, we look, because we want to understand the thing at the heart of it all. We live far from the center, in a quieter part of the galaxy, halfway out along one of the spiral arms. From here, Sagittarius A does not feel close. It does not threaten. But its presence is essential. It is the hidden compass of the Milky Way, the weight around which the galaxy balances. Every rotation, every orbit, every drift of dust and migration of stars is connected to that central point. And so we fall asleep not in a void, but in a system of order, a galaxy whose heart is not chaos, but gravity, not a blaze of light, but a steady pull. Not a god, not a guardian, but something stranger, a singular absence that shapes everything around it. The galaxy breathes, and in its center, a giant dreams. Far beyond the bright lanes of the spiral arms, beyond the warm hum of star-forming regions and the glowing arc of the galactic disk, there is a space that most eyes do not seek. It is dim, diffuse, and almost empty by comparison. There are no dense nebulae here, no newborn stars. The light is older, thinner, fainter. It does not call attention to itself. It simply persists. This is the halo of the Milky Way, a vast spherical envelope of stars, globular clusters, and invisible matter that stretches far above and below the plane of the galaxy. It is not where we live, but it surrounds us all the same, and within it, the oldest stars still shine. They do not blaze like their younger siblings. Many are too faint to see without powerful instruments, but they are there, drifting slowly, following elongated orbits that cut through the galaxy at strange angles, untouched by the neat spiraling of the arms. Some have been circling the Milky Way since before the arms themselves had formed. They are relics, fossils in motion, carrying in their light the earliest stories of the cosmos. They do not remember with words, but with chemistry, with the specific absence of heavy elements in their makeup, a kind of purity that reveals just how little time had passed between the birth of the universe and their formation. These are hyper-metal-poor stars, stellar bodies with barely any elements heavier than helium. In astronomy, metals include all elements beyond hydrogen and helium, and their scarcity in these stars marks them as ancient. They formed before supernovae had time to scatter iron and carbon widely. Their hydrogen and helium came straight from the Big Bang, and somehow they have survived the eons, untouched by violence or decay, still quietly orbiting the Milky Way in the quiet of the halo. It's easy to imagine that the galaxy has always been as it is now, with its spiral arms spinning serenely and its stars held in their familiar lanes. But the halo tells another story, one of upheaval, collisions, and absorption. The Milky Way is not a solitary creature. It has grown over billions of years by consuming smaller galaxies, pulling them into its gravity well, stripping them of stars, and absorbing them whole. What remains of those galaxies often ends up in the halo, their stars dispersed and flung into new orbits, like petals from a broken flower scattered on the wind. Some of these stars travel in long, looping streams that still carry the shape of the galaxies they once belonged to. These stellar streams arc across the sky, invisible without special tools, but unmistakable once seen. They are the ghost trails of ancient collisions, strands of memory stretched across space. Some are from dwarf galaxies the Milky Way tore apart long ago. Others come from globular clusters, slowly unraveling as they pass too close to the galactic core. In every case, the halo collects what the rest of the galaxy sheds. Globular clusters themselves are among the oldest structures we know. They orbit in the halo like old satellites, each containing hundreds of thousands of stars packed tightly together. Some are nearly as old as the universe itself. Their stars, too, speak of a different time, of a galaxy that was still finding its shape, still learning how to shine. These clusters drift slowly, high above the galactic plane, indifferent to the passage of epochs. To look at one is to look back across cosmic history, to a moment when gravity first began weaving light from chaos. The halo is not just a shell of stars. It holds something else too, something we cannot see but whose presence we can feel. Dark matter. Though we do not yet know what it is, we know it is there. It reveals itself through motion. The stars in the outer galaxy move faster than they should, if only visible matter were involved. Something unseen holds them, extends the reach of gravity, and binds the galaxy in ways that ordinary mass cannot explain. This invisible substance forms a halo even larger than the one we see, stretching far beyond the furthest stars, anchoring the Milky Way in place. Together, the stars and the dark matter create a kind of memory field, a record of everything the galaxy has gathered and become. While the disk of the Milky Way changes quickly, with stars forming and dying, arms shifting, and gas cycling through phases, the halo moves more slowly. It keeps the long view. It does not forget. The orbits of its stars preserve the motions of ancient mergers. Their chemical compositions retain the signatures of long-vanished worlds. It is not a place of creation, but of reflection. And though we live in the disk, it is the halo that quietly reminds us of where we came from. Every time we look outward, trying to measure the galaxy's shape, its age, its origins, we rely on the halo. The stars there have stories to tell, not of what the Milky Way is now, but of what it once was, and what it might have been if other galaxies had not drifted too close. They are the survivors of forgotten worlds, the echoes of structures pulled apart by time and gravity. They carry the history of violence and grace, of accretion and dissolution, of light that chose to endure. In the deep stillness of space, they keep moving, slowly, silently, orbiting a galaxy that may barely notice them now, but which would not be what it is without them. And maybe, in some quiet way, that is what memory is. Not a vivid, constant presence, but a dim light drifting far above, far behind, shaping the present from a distance. You don't need to see it to be shaped by it. You only need to know it's there, watching, circling, remembering. Galaxies are not peaceful creatures. They do not remain as they were born, spinning quietly in solitude. They move, they collide, they consume. The Milky Way, grand as it seems in its spiral grace, is not a pristine structure forged in isolation. It is a mosaic of violence, a patchwork sewn together over billions of years, its arms and stars bearing the signatures of lives once lived elsewhere. Every spiral turn is threaded with ghosts. Every quiet night sky is lit by the remnants of ancient wreckage. The Milky Way is not one story, but many, layered, fractured, and reassembled through gravity's long patience. We know this not because we watched it happen, but because the evidence is still drifting through the sky. There are stars moving where they shouldn't, on orbits that clash with the rest of the galaxy's rhythm. There are currents of motion that do not align with the spiral arms, populations of stars that do not match in age or chemistry. They are the immigrants, the orphans, the survivors. And if you follow them far enough, you begin to trace the shape of what the Milky Way has swallowed. The Sagittarius dwarf galaxy is one such remnant, still visible in the process of being devoured. It is small, fragile, and stretched, drawn thin by the Milky Way's gravity like dough in a baker's hands. Once a self-contained galaxy orbiting nearby, it strayed too close. Now it is unraveling, its stars peeling off in long tidal streams that wrap around the Milky Way's core. One day, it will be gone entirely, not in the sense of vanished, but in the way a drop of ink disappears into water. Absorbed, dispersed, changed. Its stars will mix with ours, and no one will be able to say where they came from without tracing their paths back across centuries of motion. But Sagittarius is only the most recent meal. There have been others, many others, throughout the galaxy's long history. One of the most significant was discovered not long ago, hidden in the patterns of stellar motion. It was named the Gaia sausage, not for its appearance, but as a quiet joke among scientists. Its real name is Gaia-Enceladus, a galaxy that collided with the Milky Way around 10 billion years ago. We know it was there because its stars still linger, moving on orbits that plunge through the disk in sharp, elongated paths. Unlike native stars, which orbit in neat circles around the galactic center, these stars behave like visitors, diving in and out, crossing the plane like ghosts, ignoring doors. Their chemistry tells a story too. The stars of Gaia-Enceladus are older, poorer in metals, shaped in a different environment before being folded into the Milky Way. In a way, they are fossils. Galactic archaeologists. Yes, that's a real title. Study them to piece together the timeline of our galaxy's growth, the way one might study shards of pottery to understand an ancient civilization. They don't dig through dirt. They dig through data, through motion, through light, and what they find, over and over, is the same. The Milky Way did not grow alone. It expanded by merging, by capturing, by pulling in anything that wandered too close and could not escape its gravity. Sometimes the mergers were massive, like Gaia-Enceladus. Other times, they were smaller, quieter, the galactic equivalent of a raindrop landing on a lake. But each one left a mark, a ripple, a population of stars that still move differently, still remember where they came from, even if the galaxies themselves are no longer whole. The Milky Way's halo is filled with these memories. Stellar streams arc across it like forgotten rivers, traced only by their motion. Some have names: Orphan, Helmi, Cetus. But others are still being found. They are the scattered bones of galaxies the Milky Way digested long ago. They do not fight their fate. They circle quietly now, some barely distinguishable from native stars. But beneath their surfaces, the truth remains. They came from elsewhere. This is not unique to our galaxy. It is how galaxies grow. In a universe governed by gravity, everything pulls on everything else. Over time, small galaxies fall toward larger ones. If the collision is head-on, the damage can be spectacular. The entire spiral arms torn away, cores compressed, gas clouds ignited into new starbursts. If the collision is gentle, the smaller galaxy may simply be unstitched, its stars slowly distributed into the larger one, like ingredients stirred into a cosmic soup. Either way, the result is the same. One galaxy becomes part of another. And so the Milky Way has done what galaxies do. It has taken, it has blended, it has become more than it was. If you could rewind time and watch the galaxy evolve, you would see a chaotic past. Clouds colliding, stars flung outward, tidal bridges of starlight stretching between merging systems. You would see pieces fall inward, disappear into the growing disk, and re-emerge as part of a new whole. And you would see this happen not once, but again and again. The Milky Way is not a single story, but a quilt of many smaller ones, stitched together not by choice, but by the inescapable mechanics of cosmic gravity. Even now, the process is not over. The Andromeda Galaxy is approaching. Slowly, over billions of years, it draws nearer, pulled by the same force that built the Milky Way's past. One day, they will collide. They will merge, and something new will form from the union. But that is another story, far in the future, written in the gravity between stars. For now, we live in the middle of a galaxy made from others. When you look up, you are looking at the remains of long-lost worlds. Not metaphors, not poetry. Real stars from real galaxies that once had names, shapes, with histories of their own. They did not vanish. They became part of something larger, and in doing so, they became part of you. Time on Earth is measured in breaths, heartbeats, calendar pages fluttering from the wall. It is short and sharp, marked by seasons, by aging faces, by the swift change from one morning to the next. But outside, beyond the thin veil of atmosphere that surrounds this small blue world, time stretches into something else entirely. It lengthens, softens, bends into shapes we rarely recognize. In the quiet reaches of the galaxy, time does not tick. It turns. Our sun, like all stars in the Milky Way, is not stationary. It is not fixed in place, anchored to a backdrop of stillness. It moves, tracing a wide orbit around the heart of the galaxy, a vast circuit through the Orion Spur, sweeping through space at a speed of more than 500 miles per hour. At that speed, we don't feel it. You don't feel it. You lie still, the air in your lungs calm, unaware that you are traveling an ancient path that takes eons to complete. One full orbit of the Sun around the galactic center takes roughly 225 to 250 million Earth years. That is a galactic year. You have never had one. You will never see one end. Human lives come and go in a tiny blink of that cosmic calendar. Civilizations rise and collapse in the space of a single heartbeat on that scale. Mountains grow and vanish. Oceans open and close. Even species, entire genera, flash into being and disappear again before the sun completes one lap around the center. The last time Earth was in this part of its galactic orbit, there were dinosaurs walking through lush forests, breathing the thick, warm air of the Mesozoic. There were no cities, no languages, no human minds to look up and wonder what the stars were. There were no telescopes, no questions, no names for constellations. The sky looked different. The constellations we know hadn't formed yet, because the stars themselves were in different positions, drifting slowly with time. The sun moved on through the spiral, and Earth followed quietly. Now, after one galactic year, we have arrived back here, though here is not really the same place at all, because space itself is not a fixed stage. The spiral arms rotate, stars shift. The entire galaxy changes shape over time. It breathes, stretches, grows, and the sun does not orbit in a perfect circle. Its path is a slow oscillation, a rise and fall through the galactic plane like a stone, skipping through a pond in slow motion. It drifts up, then down, then back again, taking millions of years with each cycle. Sometimes it passes through denser regions of stars and dust. Other times, it floats through more silent space. All of this happens without effort, without announcement. You are never told that you are passing through a new part of the galaxy. There is no alarm, no border crossing. But the journey continues anyway, as certain as your pulse. While you sleep, The sun carries you forward, your planet spinning around it like a dancer tracing a smaller step inside a larger waltz. The galaxy itself turns slowly. Each of its spiral arms rotates at a different rate, like the blades of a giant, uneven pinwheel. The arms are not rigid. They are waves of density, like traffic jams that move through the road even as the cars come and go. Stars pass through these arms, and the arms move too, guided by patterns deeper than sight. From far away, the galaxy appears frozen, like a painting suspended in the void. But if you could watch it across 1 billion years, you would see it move like a tide, softly, deliberately, reshaping itself as it turns. Within this dance, nothing is ever still. Every star moves, every planet follows. Even the halo stars, those drifting relics of ancient galaxies, are not fixed. They orbit the center too, but on more chaotic paths, tilted and stretched, cutting through the disk with slow persistence. The stars we see in the night sky now will not always be there. In another few million years, the sky will change. Familiar constellations will twist out of shape. New ones will form. The sky will become unfamiliar again. And yet, in this endless motion, there is something comforting. Change is not a sign of failure. Movement is not disorder. It is simply the rhythm of the galaxy. Elegant, patient, eternal. Stars are born. They orbit. They die. New stars take their place. Dust is recycled. Light travels. Shadows drift. The galaxy does not pause. And neither do we. It is strange to think that the Earth has never stood still. Not for a moment. From its earliest days as a molten rock circling the infant sun to the cooling of its surface, the rise of its oceans, the long quiet of its prehistory, it has been moving, even when there were no eyes to witness it, even when there was no name for the sky. It spun, it traveled, it turned with the sun, and the sun with the galaxy, and the galaxy through the dark corridors of the universe. Every breath you take is part of that journey. Every cell in your body, built from atoms born in stars, has known motion. You are not on the Earth. You are of it. And the Earth is not on a path. It is part of one. So, when you feel time pressing against you, when the days seem too short or the years too fast, remember that there is another clock. One that ticks so slowly you cannot hear it, but which carries you all the same. You are not late. You are not lost. You are simply moving through the arms of the galaxy, one slow curve at a time, wrapped in a spiral that has never stopped turning. The spiral arms of the Milky Way look permanent from a distance, as though they were painted into the sky and left to shine forever. Their elegant curves suggest structure, order, a grand architecture drawn with precision. But the truth is softer and more fluid. These arms are not solid. They are not fixed trails etched into space. They are patterns, illusions woven from the movement of stars and gas, like ripples across a pond that hold their shape while the water flows through. The arms are made not of particular stars, holding hands in a cosmic chain, but of many stars coming and going, their paths briefly aligned as they pass through the spiral's density. Each arm is a region where the material of the galaxy is slightly more crowded, a traffic jam in space. Stars slow down when they enter, bunching up, clustering like people at a bottleneck. And as they exit, they spread out again, drifting forward, leaving the pattern behind. The spiral is not the material itself. It is the behavior of the material. It is strange to think that the spiral arms are real, but not made of anything specific. A wave of density is not a thing you can touch. It is a pattern of relationships, a shape created by timing and gravity. Like sound through air or wind across a field of grass, the arms are expressions of a deeper rhythm. Stars pass through them, just as the Earth passes through seasons, part of a cycle they don't control, but help define. The arms form and fade over time. They are not immortal. They are not even guaranteed. Some galaxies lose their spirals entirely, becoming blurred ellipses or broken shapes. Others grow new arms, influenced by nearby galaxies or collisions long past. The Milky Way's arms have changed before, and will change again. What we call the Orion Spur, our home within this grand structure, is only a small transient branch, a side road on a vast and shifting highway. It won't last forever, but while we are here, it gives us our view of the stars. From our place in the disk, we see only part of the picture. When we look up at night and glimpse the hazy band of the Milky Way, we are looking along the plane of the spiral, not down upon it. It's like being inside a forest and trying to understand the shape of the entire landscape. We see trees, but not the shape they form. Still, through careful observation, through the patient stitching together of light, motion, and time, we have come to understand the shape we are inside. And the shape is alive with motion. The spiral arms are where stars are born in greatest numbers. Dense clouds of gas collapse under their own weight, triggered by the pressure of the wave itself. The arms, with their gentle crowding, press the raw materials of stars into motion. From this quiet compression comes ignition, and from ignition, light. Young stars burn brightly, often clustered near their birthplaces, lighting up the spiral arm before drifting away into the darker parts of the galaxy. Over time, these newborn stars outpace the arm that formed them. They do not stay behind. The stars move faster than the spiral wave. They begin their lives nestled in gas and starlight, but soon they emerge into clearer skies, having left the place of their birth behind. And the spiral, like a long exhale, continues without them. In this way, the arms are always changing in composition, never the same stars twice. The pattern remains, but the contents flow, and that is what makes them beautiful. Not permanence, but persistence. Not structure, but recurrence. They are formed by movement and remembered through rhythm. What we see as a graceful arm of stars is, in fact, a momentary gathering, held together by timing and pulled apart by time. There is something deeply comforting in this. The spiral arms are not monuments. They are not rigid cages or tracks laid down for eternity. They are fluid, responsive, organic. Their beauty lies in how they bend to motion and still hold form. Like dancers moving across a floor, each step is fleeting, but the choreography is felt long after the steps are gone. And this, too, mirrors life on Earth. We often mistake patterns for permanence. We believe the present will last, that the shape of things today defines what they are. But time moves through everything. People come and go, places change, structures rise and collapse. Yet there are patterns that persist, not because their elements are fixed, but because the forces behind them continue to move. The spiral arms teach us that beauty can arise from the temporary, that structure can be born from flow, that what looks like stability is often just balance in motion. The galaxy does not hold itself together with walls. It does so with gravity, with orbits, with gentle nudges spread across millions of years. It allows stars to move freely, and in doing so, creates patterns more lasting than stone. When you look at the Milky Way, remember that you are seeing a wave of motion, not a sculpture. You are looking at stars passing through a pattern that has outlived its builders and will outlive its passengers. You are witnessing a spiral drawn not with ink or fire, but with time. A memory made visible, a rhythm playing out in the darkness, patient and quiet. And through this rhythm, we move, not trapped, but carried, not held, but guided. We are passengers on a spiral, not of things, but of movement. And that is enough. That is everything. The stars should not be moving the way they do. If we look only at the light, the brilliant spiral arms, the glowing core, the scattered clusters of stars drifting at the edges, the galaxy seems to obey no rule. According to the pull of visible mass, The outer stars should be slowing down, like the outer edges of a spinning wheel that feels less of the center's strength. But they aren't. They move fast, too fast, as if pulled by something we cannot see, as if surrounded by a force that does not glow, that does not flicker or burn, but that holds the galaxy in its grasp all the same. This is the puzzle of dark matter, a name that offers no answers, only a placeholder for the unknown. It is not darkness in the way a room is dark or a cave is black. It is the absence of interaction. It does not absorb light. It does not emit it. It passes through the galaxy silently, invisible even to the most sensitive telescopes, leaving behind only its influence. We do not know what it is made of. We only know what it does. And what it does is everything. Without dark matter, the Milky Way would not hold together. The stars at the galaxy's edges would fly off into space, torn from their orbits by the speed of their motion. The spiral arms would unravel. The core would lose its shape. The entire structure would dissolve like dust shaken from a sheet. But it doesn't. Instead, the galaxy spins with strange consistency. From center to edge, the stars keep pace, as if held in a gentle but unyielding grip. That grip is gravity. And gravity only makes sense if there is more mass than we can see. In this way, dark matter becomes the silent architect of the Milky Way. It forms an invisible halo that surrounds the galaxy, far beyond the limits of our starlight. A sphere without a surface. A weight without a body. It is there in the way a shadow proves the shape of a tree, not by being visible itself, but by revealing what it touches. We infer its presence through rotation curves, through the motion of gas clouds, through the bending of light from distant galaxies as it passes through this hidden matter. Every test whispers the same thing. There is more here than meets the eye. It is strange to feel governed by something so unknowable, to live in a galaxy shaped not just by light, but by mystery. And yet that is the truth of our home. The stars we see are only part of the story, the glowing edge of a much deeper fabric. Most of the Milky Way's mass is invisible, and yet it holds us in orbit. It lets us exist. We tend to place faith in the visible, in the luminous, in what can be counted, measured, seen. But the galaxy teaches a gentler truth, that what we cannot see may be just as real, that the strongest forces may be the quietest ones, that presence is not always about appearance. Dark matter does not seek our attention. It makes no spectacle of itself. It is patient, passive, constant. It does not burn out. It does not explode. It does not come apart in death. It simply remains, shaping the paths of stars with a gravity so soft we didn't notice it until we tried to explain the speed of the spiral arms. There are theories, of course. Hypothetical particles like WIMPs or axions, attempts to give form to the unknown. Some suggest modifications to gravity itself, reworking the laws to match what we see. But still, the matter remains dark. Still, the questions outweigh the answers. It is a cosmic silence we are learning to listen to, even if we do not yet understand the language. And while the science unfolds in labs and observatories, the feeling remains universal. The sensation that there is more to the world than we can touch, that the seen is cradled by the unseen. The Milky Way spins inside a halo of something vast and silent, something ancient and essential. You are in it. You are part of it. And though you cannot see it, you feel its presence with every stable orbit, every tide pulled by gravity, every gentle turn of the earth beneath your feet. The galaxy is not held together by light alone. It is not merely a painting in the sky, drawn from starlight and nebulae. It is a structure suspended in shadow, held in place by forces that do not reveal themselves but never fail in their task. Without dark matter, there is no Milky Way, no spirals, no stars, no sun, no you. So tonight, as you lie still and let your thoughts drift outward, Remember that even in the quietest corners of the cosmos, something holds you, something ancient and invisible. As much a part of your world as the atoms in your bones, you are wrapped in the arms of a galaxy built from both light and silence, both fire and gravity, both what is known and what waits to be named. And in that space between knowing and not knowing, there is wonder, there is grace. There is the soft assurance that not everything must be seen to be true. Some things simply are. Some things simply hold. In the quiet dark of space, vast beyond comprehension, the Milky Way and the Andromeda Galaxy are drifting toward each other, not with the violence of a crash, but with the solemn grace of dancers approaching across a floor they've shared only in silence. They are drawn not by aggression but by gravity, pulled gently and unrelentingly by the invisible tension stretched between them. Every second that passes brings them closer, although the stars within them do not feel it. The motion is too grand, too slow, to be anything but background. But still, it is happening. In 2 billion years, they will touch. From here on Earth, that sounds like an apocalypse in waiting. 2 enormous galaxies on a collision course. Billions of stars, black holes at their cores, clouds of gas and dust and dark matter sweeping into one another like tide meeting tide. It sounds like rupture, like destruction. But that is not what galactic collisions are. There will be no fiery crash, no planetary walls torn apart in real time, no screams in the void. Instead, the galaxies will pass through one another like ghosts in a fog, their stars so far apart that even in the chaos of contact, most will never touch. They will weave together. Spiral arms will stretch and twist into long tidal tails, trailing starlight across space like brushstrokes across a black canvas. New structures will begin to form. The galaxies will loop, pull, retreat, and return, until the shapes they once held dissolve into something new. And what they become will not be a wreckage. It will be a reimagining. A single, larger galaxy will form. Elliptical, luminous, slow-turning. A merger, not a martyrdom. This is how galaxies grow. They are not fixed monuments, but evolving systems, shaped by gravity and time. The Milky Way is not innocent of this. It has done this before. Long ago, it consumed smaller companions, shredded dwarf galaxies, drawn in stars and gas from every side. Andromeda, too, has eaten its way across the sky, leaving trails of its meals still visible in its halo. These collisions are not aberrations. They are part of the cycle, and from these dances, beauty arises. Gas clouds will be stirred, shocked into motion by the changing gravitational tides. Those clouds will collapse, pulled into knots by their own weight. And in the wake of this celestial turbulence, stars will be born. Thousands, then millions, clusters of light forming in the hush that follows impact. New stars lighting up the paths where old galaxies crossed. Even now, when we simulate the future of this union, the results shimmer, not with endings, but with beginnings. It's important to remember the scale. Galaxies are mostly emptiness. The distances between stars are immense, so vast that even in a merging event, the odds of 2 stars physically colliding are vanishingly small. Instead, they dance. Orbits shift. Some stars are cast off into intergalactic space, flung outward like sparks from a grinding wheel. Others fall inward, captured by new centers of gravity. Planetary systems might feel this, yes. Some might be thrown into colder reaches or pulled toward new suns. But on the whole, the dance is graceful, not violent. When you look at Andromeda in the night sky, faint and blurred, what you're seeing is a future partner. Our galaxies are moving toward each other at hundreds of kilometers per second. At that speed, you could travel from coast to coast on Earth in less than 20 seconds. Yet the journey between the 2 galaxies still takes billions of years, because the space between them is not small. It only seems that way from here, but time is patient. The universe is not in a hurry. In the future sky, long after our species is gone or transformed beyond recognition, Andromeda will grow larger and brighter. It will swell in the heavens, no longer a faint smear, but a full companion. As the galaxies begin to merge, the stars will seem to rearrange themselves across the dome of night. Constellations will lose their shape. New shapes will form. The sky will feel deeper, denser, filled with strange alignments and new light. For whoever may be there to see it, it will feel like the sky itself is blooming. The event will take place over hundreds of millions of years. No single lifetime will witness its beginning and end. It will be an epochal transformation, quiet, majestic, full of motion and change. And in the end, the Milky Way as we know it will be no more. But it will not be lost. It will be folded into something larger. We already see evidence of this kind of growth in galaxies scattered across the universe. We see tidal streams, arcing rivers of stars flowing through halos. We see bridges between galaxies, light stretched into ropes across millions of light years. We see knots of starbirth where clouds collided. We see galaxies that once were two and now are one, still bearing the faint traces of their former shapes like scars that shimmer instead of wound. And we know this will be us. There is comfort in that, strange as it may seem, to know that even the galaxy is not fixed, that the structures we think of as permanent are really only pauses in motion, that everything is allowed to change. So much of life is spent fearing collision, bracing for what it will break. But galaxies do not brace. They bend, they flow, they give way and grow. Their paths are not resistances, but invitations to transformation. We are inside something that will one day become something else. And in the night, when you look up, remember that the quiet stars above you are not standing still. They are drifting through a sea of gravity, pulled ever closer to an ancient partner. One day, long from now, they will meet, not in violence, not in fire, but in a long embrace, slow as time, vast as space, beautiful beyond belief. Stars are supposed to stay with their kin. Born in nurseries with dozens, hundreds, sometimes thousands of siblings, they emerge from the same clouds of dust and gas, shaped by the same gravity, warmed into ignition by the same quiet pressure. Most of them remain nearby, caught in the spiral rhythms of the galaxy, following slow arcs that keep them tethered to the family they began with. But not all stars stay where they're supposed to. Some go rogue. Some are flung. In the vast disk of the Milky Way, among its arms and lanes and drifting halos, there are stars that move far too fast, streaking through space with the cold fire of exile. They do not orbit like the rest. They do not trace the elegant loops around the galactic center that most stars follow. Instead, they cut across those paths, like sparks flung from a wheel, like stones skipping out from the core of the spiral. These are hypervelocity stars, moving so quickly that not even the galaxy itself can hold them. The speeds are staggering. A typical star orbits the center of the Milky Way at a few hundred kilometers per second, but a hypervelocity star can travel more than twice that. Some exceed 0 kilometers per second. At those speeds, they are not merely fast, they are escaping. They are on trajectories that will carry them out of the galaxy entirely, forever. These stars begin, often, at the heart of the Milky Way, near the monstrous presence of the supermassive black hole known as Sagittarius A. There, among dense clouds and packed stellar clusters, gravity reigns with absolute authority. Binary stars, pairs born together, bound in mutual orbit, wander too close to that sleeping giant, and what was once a shared life becomes a cosmic judgment. The black hole seizes one star and devours it, and the other, in the process, is flung outward with a velocity so great that it breaks free of everything it once knew. What follows is silence. The ejected star begins a solitary journey, arcing out from the crowded core into the thinner arms, the fainter edges, and eventually beyond the furthest gravitational handholds of the galaxy. It leaves behind its birthplace, its sibling, and the starlit swirl of the Milky Way itself. From there, it sails through intergalactic space, alone. This is not the only way a star can go rogue. Binary systems are fragile in other ways, too. A supernova, the explosive death of one partner, can rupture the balance. The shockwave and sudden mass loss can send the remaining star careening into new territory. And the dance of galaxies themselves, mergers, encounters, tidal disruptions, can scatter stars like seeds in wind, tossing them into new skies, unmoored. Most of the stars that wander are not hypervelocity. They do not escape the galaxy entirely, but they do end up far from where they started. As the Milky Way turns, as gravitational tides shift and overlap, stars drift. They migrate. Some from the halo fall inward, some from the arms float out. Over billions of years, they settle into places where nothing remembers their origin story. Their motion is slow, unremarkable, barely different from the stars around them, but they are not from here. And, in that subtle difference, an unusual speed, a rare composition, a strange angle of motion, astronomers find stories written in silence. They find the memory of collisions long past, of lost companions, of galaxies devoured, of clusters unraveled. These stars are messengers from a deeper history, speaking not in words but in trajectories. The galaxy is full of travelers. They pass through regions of gas and dust where no star was born. They cross arms they had no part in shaping. They shine on planets they will never visit, offering light for a time before drifting on. If they could speak, perhaps they would not call themselves alone. Perhaps their path through the dark is not exile, but pilgrimage. But from our vantage, from our small and stable orbit, they seem like echoes of catastrophes, each one carrying the ghost of a rupture. And yet they still shine. Even the most solitary star still burns with fusion at its core, still radiates warmth, still pulls planets, perhaps, in quiet ellipses, still offers light to any eye lucky enough to catch it crossing the night. We see them sometimes, strangers in the survey maps, stars that do not fit. They remind us that the galaxy is not just structure and symmetry. It is disruption, too. It is surprise. It is movement we do not always understand. In the deep halo, in the shadows between arms, in the long tail of a galaxy not yet finished forming, these quiet travelers persist. Some will take hundreds of millions of years to reach the edge of the galaxy. Some will pass into the space between galaxies and wander there forever, growing older and redder and dimmer, until even they fade into the temperature of the void. But some will be found, measured, studied, their paths retraced, their stories pieced together, because the galaxy is a place of connection, but it is also a place of parting. Not all stars stay. Not all stars belong to where they are. You, too, are made from atoms born in places you will never see, scattered by stars long dead, brought together by chance and time. There is stardust in your bones that once drifted alone across the dark, waiting for a gravity to call it home. And perhaps, like those rogue stars, you carry with you the quiet memory of a disruption that set you free. And still, you shine. The Milky Way is not perfect. It is not balanced like a child's drawing of a spiral, arms curled in identical sweeps around a serene, motionless center. It is not a machine, not a clockwork wheel spinning in silence. Instead, the galaxy leans, it dips, it stretches, it ripples like a sheet of water disturbed by stones thrown long ago. What we live inside is not symmetrical. It is lopsided, like something mid-step, like something still becoming. If you could rise far above the disk and look down, far enough to see not just the stars, but but the shape they trace. You might expect to find a clean, flat spiral, arms radiating outward in orderly beauty. But that is not what you would see. The outer disk is bent, as if someone lifted the edges and let them flutter. One side of the galaxy tilts up, the other down. The shape is warped, like a record left too long in the heat. It swells in unexpected places. It sinks in others. This warp is not a flaw. It is a history. For a long time, we didn't know it was there. We live embedded within the galaxy's plane, surrounded by dust and light in vast distances, and it is difficult to sense the shape of something so large when you are inside it. But as radio telescopes began to map the hydrogen gas beyond what our eyes can see, they traced the arcs of matter bending away from the expected line. Like a bruise showing under the skin, the warp revealed itself only through a different kind of vision. There are many reasons for it, none of them simple. Some blame the gravitational pulls of nearby satellite galaxies, smaller companions like the large and small Magellanic Clouds, that tug on the Milky Way with persistent fingers, dragging its edges out of place. These galaxies orbit us, but they are not passive. They pull, they disturb. Their motions send ripples through the dark matter halo, which in turn tugs on the disk, like wind dragging across water. Others look deeper. They see signs of ancient mergers, long ago collisions with other galaxies that left behind streams of stars and gravitational scars. These scars may still echo through the disk, causing it to flex and sway, like a bell that has not stopped ringing. Or perhaps the warp is a resonance, a natural oscillation of the disk itself, excited by invisible patterns in the galaxy's mass, dark matter, magnetic fields, the ghosts of past alignments. Whatever the cause, the result is unmistakable. The Milky Way is not still. Its disk breathes. It heaves upward, then downward, in a motion so slow and grand we can only capture it across decades of study and generations of tools. The stars ride this wave. The gas flows with it. The spiral arms ripple like flags in a wind we cannot feel. Even our sun, with all its planets in tow, is not following a simple path. It bobs above and below the galactic plane, tracing a gentle oscillation as it orbits, like a buoy riding swells on a tide that takes millions of years to turn. This motion is not a threat. It is a reminder that even the vastest structures we know are not static, that the galaxy is not an object, but a process. It is not a finished shape, but a living motion. Galaxies bend. They breathe. They respond to touch. Every passing mass, every encounter with a smaller galaxy, every movement within their own dark matter, halos leaves an imprint. And over time, those imprints become structure. They become beauty. We often think of space as cold and quiet, and it is, but it is also full of motion, not the chaotic kind we see in storms or oceans, but a deeper, slower rhythm. The kind of motion that takes hundreds of millions of years to complete a single gesture. The kind that is felt more than seen. The warp of the Milky Way is one of these gestures. Subtle, wide, graceful. When we map it, we see that the disk is not just warped, but twisted. The direction of the warp changes with distance from the center, creating a kind of corkscrew shape in the gas and stars. The galaxy does not just bend, it spirals in its bending. And we do not know yet if this is temporary or permanent, whether the warp will fade over time or deepen with each galactic breath. Perhaps the most beautiful thing is this: we are inside that motion. Our star is a participant in the galaxy's flexing shape. We rise and fall with the disk's breath. We orbit through a structure that is not still, that is not perfect, that is not what we once imagined. And in that imperfection, there is truth. No spiral is forever. No disk is perfectly flat. No system, no matter how grand, is untouched by what surrounds it. The Milky Way's warp reminds us that even the largest things can be unsettled, That symmetry is not a prerequisite for stability. That beauty can come from motion and meaning from asymmetry. That what we live within is not only a galaxy of stars, but a galaxy of memory and motion, of tides and tugs, of histories still unfolding in shape. We are not passengers on a still plane. We are riders on a ripple, borne forward by gravity and time. And the galaxy, our home, is still becoming. Above your quiet room, far beyond the atmosphere and its blanket of weather, past the highest clouds and even the silence of orbit, the galaxy hums, not with sound, but with light we cannot see. It is a layered, hidden symphony that never stops playing. The stars you glimpse with your eyes are only one register in this cosmic orchestra. There are frequencies stretched wide on either side of visible light, unseen but always there, bathing every inch of the Milky Way in radiation, in motion, in memory. The sky is alive with wavelengths your body cannot feel, but they pass through you all the same. Radio waves roll long and low across the galaxy, rising out of clouds of cold hydrogen gas that drift between stars like soft ghosts. They are ancient, these signals, emitted not in bursts, but in a steady breath, carrying the quiet hum of neutral atoms. Radio telescopes, with their wide, curved mouths, drink in this hidden glow. They show us a galaxy shaped not just by light, but by shadow and structure. Where your eyes see darkness between stars, radio maps find tendrils of gas and curls of cloud, whispering the story of how stars are born and where they gather. And there are other, stranger sources, pulsars, and neutron stars left behind when massive suns collapse, spin like cosmic lighthouses, their beams slicing through space with millisecond precision. These dead stars, denser than thought should allow, send out rhythmic signals in radio and beyond, ticking in the dark with eerie consistency. Some rotate hundreds of times per second, each pulse a relic of catastrophe, a reminder that endings can echo forever. But not all messages are slow and soft. From supernovae, the explosions that unmake stars in brilliant, final gestures, come fiercer emissions. X-rays pour from the wreckage, streaming from the shock waves as they race through space, heating surrounding gas to millions of degrees. The remnants left behind glow not with heat we can feel, but with energy we must translate, like finding fire in a language of mathematics. In those expanding shells of destruction, the galaxy remembers its own cycles. Death fuels creation. The blast of a supernova seeds clouds with heavy elements, presses on nearby dust, and sometimes begins again what just ended. Farther up the spectrum, gamma rays scream. These are the highest energy photons the universe can produce, emitted in rare, violent bursts. Black holes devouring matter, magnetars cracking under their own intensity, particle collisions in the heart of dying galaxies. The Milky Way carries its own signatures in this energy, much of it still mysterious, its origins scattered across the core, the halo, the spiral arms. Gamma rays pass through us unnoticed, but they are not absent. They trace the edges of what we do not yet understand. Perhaps the most haunting structures in this invisible galaxy are the Fermi bubbles. Discovered only recently, these enormous lobes of gamma-ray light balloon above and below the galactic plane, extending tens of thousands of light years out from the center. They shine in frequencies we cannot see, glowing like faint bruises in the X-ray sky. We don't know what made them. Some think they are the remains of an outburst from Sagittarius A, the supermassive black hole at the galaxy's core. Others see the fingerprints of stellar winds or ancient collisions. Whatever their origin, they are real, towering structures of energy that tell us the galaxy has moods, has memory, has moments of dramatic breath and silence. Cosmic rays thread through all of this, not light at all, but particles. Protons, electrons, atomic nuclei. racing at near light speed, flung from exploding stars, from distant galaxies, from sources still unknown. They strike our atmosphere constantly, a gentle, invisible rain. Some pass straight through you without pause. Others crash into molecules in the upper air, setting off cascades that light up detectors in remote places. They are messengers without voices, arriving long after their origins have disappeared. Together, these layers, radio, X-ray, gamma, particle, make up a galaxy we cannot touch or see, but that touches and sees us all the same. This invisible Milky Way exists not above the one we know, but within it, around it, beneath it. Every starlit view from Earth is only one narrow slit in a grander story, one color in a hidden canvas. To understand the galaxy is to understand that our senses are not enough. What we call dark is often just unlit. What we think is silent may be humming in a key we cannot hear. The galaxy is full of soundless explosions, of glowing ruins, of unseen tides of energy that rise and fall across distances too great for thought to carry. Our machines, our telescopes, our algorithms give us access to these other realities. They translate the unseeable into form. They whisper the secrets of stars that died before our ancestors first shaped fire. And in this hum of invisible light, we find ourselves again, made of matter thrown from ancient supernovae, held together by the gravity of things we can't perceive, bathed in a sky whose true face is always hidden, yet always shining. You sleep beneath this sky every night. Your body, warm and quiet, drifts under sheets of radiation so soft you never feel them. But they are there, passing through your window, woven into the air, crossing the world in waves too wide, too deep, too fast to notice. They have been here longer than you. They will remain long after. The galaxy is not silent. It sings in frequencies you were never meant to hear. Between the stars, in the long silence of the galactic arms, there is more than dust and radiation. There is potential, not merely the mechanical kind that predicts future motion, but the quiet possibility of life waiting to happen. The Milky Way is not just a structure of stars and gas. It is a cradle stretched across 100,000 light years, full of places where chemistry leans toward biology, where the ingredients of life drift in clouds, and where planets circle suns in gentle balance. In the stillness of night, while you sleep, these possibilities unfold, unseen and undisturbed. Within the disk of the galaxy lies what scientists call the Galactic Habitable Zone, a region not too close to the dangerous activity of the center, not too far out in the cold, sparse halo. Here, the density of stars is enough to form planets, but not so dense that gravitational chaos tears them apart. Radiation is manageable. Heavy elements, forged in ancient stars, are present in enough abundance to make rocky planets, oceans, and organic molecules. It's a zone of moderation in a universe of extremes, and it's where Earth finds itself, well placed in a spiral arm, orbiting an unremarkable star with just the right conditions. But Earth is not the only experiment. The Milky Way is estimated to contain over 100 billion stars. Even if a small fraction of them host planets in their own habitable zones, the numbers swell beyond imagining. Trillions of potential homes. Trillions of chemical stories unfolding in parallel. Some are likely sterile, lonely stones, orbiting red dwarfs in frozen silence. But some may not be. Some may harbor warmth, atmospheres, oceans that rock gently under foreign skies. Life that never heard of Earth, never needed it, never looked up to wonder about the stars because it never left the sea. Even in the spaces between stars, the galaxy breathes with possibility. Dust clouds, cold, dark, and vast, carry organic compounds, the carbon chains that form the skeletons of biology. In these clouds, unlit by stars, molecules like formaldehyde, methanol, and even amino acid precursors have been detected, floating in the dark like messages not yet opened. These compounds form in the icy shells of dust grains, triggered by ultraviolet light or cosmic rays. They drift, slow and silent, waiting for the next collision, the next star, the next planet. You could call them seeds, not of life itself, but of the conditions that make life more likely. They are not rare. The chemistry of life, it turns out, is not exotic. It is mundane, even ordinary. The galaxy does not hoard it. It scatters it everywhere, from comets at the edge of solar systems to the thick belts of gas around newborn stars. This is not a galaxy of barren space, but of subtle readiness. On some planets, those molecules might combine in shallow seas, sparked by heat and lightning, by radiation and time. Proteins might coil, membranes might form, and something that is not alive might slowly become something that is. The transition is not fast. It does not happen in a single moment, but the conditions for it are not rare, not strange. In fact, they may be the rule, not the exception. Even moons may not be exempt. Jupiter's Europa and Saturn's Enceladus, within our own system, hide subsurface oceans beneath crusts of ice, warmed by tidal forces and laced with organics. They are whispers of what might be common. Oceans do not need sunlight. Life does not require air. The galaxy may be full of warmth hiding in cold places, of motion inside silence. We do not yet know how common life is, but the Milky Way, if nothing else, seems to prepare for it. And preparation is a kind of invitation. Every supernova, every dying star enriches the interstellar medium with elements that life needs: carbon, nitrogen, oxygen, phosphorus, sulfur, iron. These are the bones of cells, the iron in your blood, the molecules in your DNA. They are thrown outward in death and recycled into new clouds, new stars, new planets. The galaxy has done this for billions of years, a quiet act of cosmic generosity. You are here because of it. You, a being of water and salt, built from star wreckage and old hydrogen, are not separate from this potential. You are one of its outcomes. You are one of its questions, answered. The Milky Way has already produced life, at least once. That alone should bend your idea of what the galaxy is. It is not only a structure of matter and motion. It is a history of chances taken, a field of ongoing experiments, a book with pages still being written in molecules and atmospheres and the slow chemistry of distant worlds. Somewhere, perhaps, others are reading their own versions of this story, not in words, not in languages you would recognize, but in pulses of sensation, in chemical exchanges, in thought that may be utterly different from ours. Or perhaps life is rare beyond comprehension, and we are alone in the dark. But even if that's true, the potential remains, because the galaxy is alive with it. Not alive in the way a star is alive, not in flame or fusion, but in readiness, in its endless capacity to form, to mix, to warm, to combine. It does not choose to create life, but it allows for it, again and again, in more places than we will likely ever know. And that is a kind of kindness. The Milky Way is not a sterile machine spinning through nothing. It is a vast, ancient canvas smeared with the ingredients of biology, soaked in the residue of dying stars, lit by the fire of new ones, and lined with planets that might, even now, be blooming in silence. You were not born outside of it. You are what it does. Your breath rises and falls like tides drawn, not by the moon, but by something older, something quieter. As your body softens into sleep, you may imagine yourself curled within the arms of your bed, the weight of blankets drawing you inward. But what cradles you is much larger than cotton or silence. What holds you is the galaxy itself, not just around you, but through you. The Milky Way does not loom above as a distant spectacle, unreachable and aloof. It pulses in your chest. It spirals in your blood. Its long memory is written in your bones. You are not watching it from afar. You are it, condensed and breathing. The same elements that flow through distant nebulae now move gently through your lungs. The iron in your veins was smelted in the core of a dying star before Earth ever cooled. The calcium in your teeth, the carbon in your cells, the oxygen in your next breath, all of it came from explosions and quiet accretions across billions of years. You are not a visitor here. You are a native. There's comfort in remembering that you don't live inside the Milky Way like a passenger aboard a ship. You are woven from it. You are one of its self-reflective expressions, aware for a time, fragile for a while, glowing with the borrowed heat of distant fusion. When you close your eyes, you return to it more fully, not as a concept, but as a truth you feel in your bones. Sleep is not departure. It is reunion. And what a place to return to. You drift in a galaxy of over 100 billion stars, each with its own story of birth, brilliance, and dimming. Some spin rapidly with intense light. Some are quietly cooling. Others long dead, their light still touching your world like a postcard from the past. But all of them, every single one, are your kin. Not metaphorically, not poetically, literally. They are your shared ancestry, your extended family glowing across gulfs of space. Imagine that for a moment. Let it settle. Your origin story is written not in a single place, but in many. You were scattered before you were gathered. You were dust before you were breath. The atoms in your body took long, winding routes through collapsing clouds and shattered worlds. Before they belonged to you, they may have been part of a comet, a raindrop, a dinosaur's femur, a volcanic plume, a tree's sap, and even before that, long before Earth. Those atoms rode inside stars that pulsed and burned and burst. You were made from many suns, some of them still visible in the sky tonight. So you see, you are not small. You are wide, and in this widening, you carry memory not in your mind, but in your matter. You remember the galaxy, the way roots remember rain, without needing to be taught. You belong to it in a way that predates language, predates birth, predates even biology. Your aliveness is simply its light moving in a new pattern, brief and beautiful. And like the stars, you, too, will change form. You will return, in time, to the quiet spaces you came from. Your atoms will loosen and drift, and eventually rejoin the swirling paths of the galaxy's dance. Nothing is wasted here. Nothing is truly lost. The galaxy does not erase. It recycles, it reuses, it rewrites. You may one day be part of a leaf, a lake, a lung, or even another thinking mind on some future shore. Your presence here is not a single moment. It is a chapter in an unending story. So as you fall asleep, let yourself feel the truth of this. You are not alone, not in the cosmic sense, not in the elemental sense. You are surrounded by the very substance that formed you and held in the momentum of a spiral that has carried stars across eons. Above you, the Milky Way does not just shimmer. It sings. In wavelengths your ears cannot hear. In light your eyes cannot see. In rhythms your heart already follows. The arms of the galaxy are not fixed lines. They are waves, rising, falling, folding inward, always moving, and you move with them. Every second, you are carried by the momentum of billions of years, orbiting the galactic center at speeds too great to feel, yet too gentle to disturb your sleep. You are coasting through space, unbothered and held. You are drifting through beauty, not away from it. All of this without needing to do a thing. No striving, no reaching, just being. You are already everything you need to be. A constellation drawn not in stars, but in cells. A story that began long before you knew it had. A child of dust and gravity and ancient fire, resting now in the curve of a spiral arm that sings to itself in ultraviolet lullabies. So close your eyes. Let go of the questions that circle you like satellites. Let go of the days and the hours. Let go of the weight of thinking. Tonight, your mind can be a quiet moon, reflecting only what it needs. The rest can wait. The galaxy turns without needing your effort. The stars shine whether you watch or not. The dark is not empty. It is simply deep. And in that depth, you are known. Not by name, not by face, but by form, by chemistry, by motion. You are one more glowing thread in a vast celestial tapestry, flickering now as you fall inward toward sleep. Good night, child of the galaxy. The stars are not far away. They are home.